Hello students, in this video we are going to solve most of the important MCQs which have been asked in the various entrance exam, and the chapter is solutions, which is also known as solution and colligative properties. So here we have first question. Find the mass of a dibasic acid. Students, first of all, the meaning of dibasic acid means dibasic acid. It means that it is having 2 H plus ion. Okay, you have to remember this. Now, and its molar mass is given. Molar mass, yes, it is M2. It is given 200, and in its 0.1 decimeter cube, it means the volume is given. Volume is 0.1 decimeter cube, or I can write it 0.1 liters. Okay. Now, after this, let us focus on the question. Find the mass of the dibasic acid. Means we have to find out W2. Okay. So before we proceed, let us see. They have given one more information, that is decinormal strength. Decinormal strength means it is 1 upon 10 normal. Okay. So what are we going to do is, it means the normality is given. Okay, normality is given as 1 upon 10 n. Fine, I'll use blue pen only. So it is 0.1 normal. So looking at the information which is given, it means we have to make use of normality formula. Okay, and what is the formula of normality? Normality is equal to number of gram equivalent of solute, in this case our solute is acid, upon volume of solution in liters. Okay, now normality, it is already given. It is 1 upon 10, so I have just substituted the value. Now number of gram equivalent of a solute, it means mass of the solute, okay, upon equivalent mass, all right, into volume of solution in liters is already given. It is 0.1. Okay, from here I have just substituted the value. Now the question is how to find out equivalent mass of a dibasic acid. Okay, now equivalent mass of an acid is equal to molar mass of that acid upon number of replaceable H plus ions. Okay students, number of replaceable H plus ions. Just have a look. Molar mass is given, it is 200, and how many replaceable H plus are there? There are 2 H plus ion because it is dibasic acid. Okay, so I will write 2. Now what I do is, I will just copy this entire expression below. Okay, so I write 1 upon 10 is equal to W2 upon 200 upon 2 into 0.1. Alright, so 1 upon 10 is equal to W2 upon 100 into 0.1. Fine. So 1 upon 10 can be written as 0.1. 100 into 0.1 would be what? It would be 10, isn't it? So I write 10 over here and W2. So here we get W2 is equal to 10 into 1 is 1. 10 into 1 is 10. Decimal if you put, you will be getting 1.0 gram. Okay. So what is the answer? The mass of dibasic acid is 1 gram. Okay. So in this way, we have to solve the MCQ in the exams, but definitely we have to solve it quickly. When you will practice this type of numericals, I guarantee you will be able to solve it quickly. So let us move to the next numerical of the day. Now let us read this question. 100 ml centimeter cube can be written as ml also. Okay, 100 ml of 1.5% solution of urea. So I write urea, and what is the percentage given? 1.5% means W2 is 1.5 gram. Okay, and urea's molar mass, we should know that it is 60. Okay, because it is NH2 C double bond O NH2. So students, merely by reading this statement, 100 centimeter cube of 1.5 percentage solution of urea, I have written 1.5 gram and M2 and formula also. Okay, now what is the volume of this? Volume is 100 ml. Okay, now that side I am going to write information about 100 ml of, so this is also 100 ml. Okay, 3.42 grams, 3.42 percentage means 3.42 grams of sucrose. So here is the information of sucrose given. Alright, I wrote sucrose and 3.42, definitely I'll write molecular mass also of the sucrose. It is 342 grams. Okay, it is C12H22O11. When you substitute the values of their atomic masses, you will get value 342. Now what is the question? So these two solutions, okay, V1 and V2, these two solutions, they are mixing. Fine. Now when they are mixing these two solutions, okay, so urea and sucrose, they are mixing these two solutions. After mixing at 293 Kelvin, what is the osmotic pressure? Alright. Now so far from the theory concept, you might be knowing that the formula for osmotic pressure, that is pi is the symbol, it is CRT. Okay, students, we have T with us. R value also is known. I will write down, yes, it is given also. R value we know. Now basically in this numerical we have to focus on concentration. How to find out the concentration of the solution which is formed by mixing two solutions. Okay, so what I write here is, I would write here concentration of combined solution. Okay, concentration of combined solution would be total number of moles which are present. Total number of moles. Okay, both the solutions moles we have to calculate, and V1 plus V2. Alright, now first I write here sucrose. For sucrose, how I will find out the number of moles? It would be 3.42, okay, mass upon molar mass, 342. So I got 0.01 for sucrose. Okay, now we will find out for urea also. So for urea, the number of moles would be 1.5 upon 60, that is 0.025. Now what we will do is, concentration of combined solution is equal to total number of moles, no? So 0.01 plus 0.025, okay, upon V1 plus V2. Directly I write 200. But remember, I have written in ml, okay? We want in liters, so I put 1000 above, okay? So concentration is going to be 0.035 upon 200 into 1000. Okay, so I cancel these two zeros, 2 ones are 2 and 5. So instead of C, what I am going to write is 0.035, okay, multiply by 5. Now what we have to do is, pi is equal to concentration value we know 0.035 into 5. Now T and R value is given 0.82, okay, 0.82. So I will write here 0.82, and temperature also it is given, it is 293. Okay, so I'll write 293. Now you pause the video and solve this and just see what answer you get. Yes, when you will solve this, you will be getting answer as 4.2 atm. Okay, it is 4.2 atmosphere. So we have solved this numerical wherein we have to find out first the concentration of combined solution. Okay, so here we have one more question based on osmotic pressure of the blood is 8. So pi is equal to 8.21 atm, and temperature is given, it is 310. What is the quantity of glucose? Means mass of the solute to be used for an injection so that it would give same osmotic pressure as that of blood. It's a very simple numerical wherein we have to find out W2. Now quantity of glucose. So it means over here we should know the molar mass of glucose. So when you calculate this molar mass, 6 into 12 plus 2, 6 into 16, okay, you will be getting 180. All right. Now, so we move on to this aspect, how to solve it. So we are having pi is equal to CRT. Okay, pi is equal to CRT, and what is concentration? Number of moles upon volume. Okay, number of moles upon volume, and it is CRT. Okay, then we are having pi is equal to number of moles W2 upon M2 into VRT. Okay, so how are we going to solve this? It will be pi is equal to CRT. Fine. Now pi is equal to C means it is mass of the solute upon molar mass into R and T. So I'll keep W2 on one side and I'll shift all terms to the other side. M2 upon RT. Students, we just have to substitute the value. Okay, W2 is equal to pi is already given. It is 8.21. Okay, 8.21 multiplied by molar mass is 180, and R is also given in this case. R is 0.0821. Okay, R value will be given in the exam, so 0.0. Okay, it is liter per atmosphere. Then yes, we have temperature 310. Fine. So what you have to do is, when you will be solving this, okay, you will be getting answer as you will be getting 1800 upon 31, and later on when you solve it, you will be getting answer as 58.06. okay, now this is the grams what you are getting. So let us solve one more question based on a different concept. When this much amount of compound is added to 28 ml of benzene, okay, density is given for the benzene, it lowers the freezing point from this to this. Okay, now we should know that lowering of freezing point, the formula of delta T is T naught minus TF. Okay, whereas T naught is what? It is the freezing point of solvent. Okay, and this is the freezing point of solution. Now they have said that freezing point lowers from this to this. It means a T naught value is given 5.51 degrees centigrade, and TF is given 5.0 degree centigrade. Okay, so delta TF here itself, if we calculate T naught minus this, that is 5.51 minus 5.0, we would be getting answer here as 0.51 degrees centigrade. Okay, let us read the further part. If Kf is given, calculate the molar mass. Now students, we all should remember what is the formula wherein we have Kf and we have Tf. The formula which we use is delta Tf is equal to Kfm. Okay, Kfm. Now delta Tf is equal to Kf. What is m? M is molality, and molality is mass of the solute upon molar mass into mass of solvent in kg. Okay, it is mass of solvent in kg. Now what we have to find out? We have to find out molar mass. So students, this we have to find out, M2. Do we have W2 with us? Yes, we have W2 with us. It is 0.322 gram. Okay. Do we have Kf with us? Yes, Kf is also given. So this is there, this is there. In fact, delta T also we are having. Now we have to find out mass of the solvent in kg. How are we going to find out the mass of solvent in kg? For this, they have given us the information of density. So density of the solvent is equal to mass upon volume. Okay, so what I will write? Mass is equal to density into volume. So density is given, it is 0.879, okay, multiplied by mass. So density is 0.879 and volume is 28. Okay, I'm so sorry, so much of noise is there in the background, but I wanted to make this video so that you can see this how to solve these numericals. So what we will do is, this is mass of solvent in kg. Okay, this value I'll substitute over here. Fine. So we are getting here delta TF is equal to KF W2 upon M2 into, just see what I am going to do now. I'll just substitute this value over here, 0.879 into 28. Now what we will do is, since we have to find out M2, keep M2 on one side. M2 will go up. So you will get KF into W2 upon delta TF into 0.879 into 28. Okay, now I will substitute the values. KF is given 5.12, W2 is 0.322 upon delta TF we have solved 0.51, and rest I just copy as it is. Okay, you can use logarithm if you want to use, and yes, make sure that this value which we have calculated will come in grams. Okay, but we want in kg, so in the numerator we'll multiply by 1000. Okay, so you solve this and just cross check, are you getting this answer? 131.3 gram per mole. Okay, so this is the answer for the molar mass. I hope you have understood. Look at these steps once again. Delta TF is equal to KFM and M is the molality. Okay, so in this way we have solved this numerical. Yes, here we have another question. If phosphoric acid solution is considered of 5 molarity, its normality would be. Now first of all, we'll have to write down the relation between normality and molarity over here. Okay, normality is equal to molarity into valency factor. Okay, now what is valency factor in case of an acid? It is the number of replaceable H plus ions. Now in case of phosphoric acid, how many H plus ions are there? Replaceable H plus ions, there are 3, isn't it? So it is going to be 15. So what is the answer of this question? Answer is normality of H3PO4 is 15N. Okay, so it is 15N is the answer. If solution is considered of 5 molarity, what would be its normality? Normality will be 15N. Now the question is, lowering in vapor pressure will be maximum for which solution? Whether it is urea, whether it is glucose, okay, whether it is magnesium sulfate, or whether it is barium chloride. Now this should be very clear in our mind that what is vapor pressure. Vapor pressure is the pressure exerted by the vapors, okay, which are present on the liquid, isn't it? Suppose if this is a beaker, okay, and it is closed with a lid, okay, and there is a solvent into it. Now this solvent, molecules which are there at the surface will evaporate and they become vapor. Okay, now because this lid is kept on the beaker, these vapors cannot escape. So what will happen? These vapors will exert the pressure on the surface of the liquid. That is vapor pressure. So vapor pressure, that is Vp, definitely depends on the number of particles which are getting converted to vapor phase, isn't it? So more is the number of particles which are escaping into the vapor phase, more will be the vapor pressure. Okay, now, but the question is lowering in vapor pressure. So what is going to happen is, if less particles are there, less vapor pressure will be there. Okay, let us see how we can solve this question. Now in case of urea, it is not having ions. Its particle is molecule, no ions are there. In this case also no ions are there. Okay, but in case of magnesium sulfate, there are 2 ions. There are 2 ions. Okay, so number of ions are 2 per molecule. We have 2 ions. Whereas barium chloride, we are having 3 particles. 3 ions are there. Just see, Ba plus 2 1 and chlorine is also 2. So there are 3 ions. Now what is happening? If there are solute particles are more is the number of solute particles into the solvent, then what will happen? The number of solvent molecules which are approaching or reaching in vapor phase would be less. Okay, so more is the number of ions in the solution. Okay, what is going to happen? More will be the lowering of vapor pressure. Okay, so according to this, our option is D. Fine. Now, let us look at this question. At same temperature, following pair of solution is isotonic. First of all, the meaning of isotonic is what? Exerting same osmotic pressure. Exerting same osmotic pressure. Now, osmotic pressure depends on the number of particles which are present inside the solution. Now, if number of particles are same, then osmotic pressure would be same, and then we say solutions are isotonic. So basically we have to find out in this case, in which case this solution is having same ions. Okay, same number of ions. Have a look at this. It would be 2 Na plus and 1 SO4. Okay, so 2 Na plus and 1 SO4 minus. So particles are 3. Okay, here what will happen? Calcium is not visible. Calcium, and we are having NO3 minus 1, 2. So add these two, here also 3 are there. So till the time what we have discussed, this could be the answer. Let us look at the other examples as well. Now here students, it is not having ions. No ions. No ions. Okay. In this case, we are having 2 particles, that is Na plus and Cl minus. Here also 2 particles. Okay, in this case no ions, and in this case there are 3 particles. Now basically if you look at all the options, the option which we are having best is this, where number of particles are same. Now next question is, following solution produces maximum elevation in boiling point. Now when there will be maximum elevation in the boiling point? When number of particles are more, it would lead to more elevation in the boiling point. Okay, now in this case it is a molecule. It is molecule. In this case barium chloride. So we know the formula, it is BaCl2, means particles would be 3. Okay, in comparison to this it is 1. Now fructose also, the basic molecule is a particle, it will not ionize. So 1. Sodium chloride, if you see, sodium plus chlorine minus, chloride minus 2. So just see again, in this case barium chloride is having more number of particles. So more number of particles are there, number of ions are more. What will happen? The elevation in boiling point would be more. More time it will take to boil that solution. So our answer would be second option. Yes, here we have one more question wherein it is given that osmotic pressure of 5% glucose solution is P1 and 5% urea solution is P2. Okay, then which solution will be having, then what will be the relation between P1 and P2? That we will find out. Okay, see students, this cannot be the answer 100%. This cannot be the answer, that is also sure. It means we have to find out whether this is the case or second is the option. Okay, answer for us. Now how you will solve it? First of all, we are going to write down the formula. It is pi is equal to CRT, isn't it? CRT means what? It is mass upon molar mass, and then RT. Fine. Now in this case you will see that mass is same, isn't it? 5 and 5. What is different is only molar mass, isn't it? R and T also would be same. So there is a relation, direct relation between the osmotic pressure and the molar mass. Just have a look at this particular example. More is the molar mass. More is the molar mass. What is going to happen? Osmotic pressure is going to be less because they are inversely proportional, isn't it? So let us check now in which case the molar mass is more. Okay, now for glucose we know it is 180, and for urea we should know it is 60. Why I have written this? Because the formula is C6H12O6 and here it is NH2CONH2. So just see, if we have to compare pi is equal to W2 RT upon M2, have a look at this. For glucose, I'll write here 180, isn't it? And for urea, I'm going to write 60, isn't it? Now, what are we trying to find out? What is the relation between P1 and P2? P1 and P2. Suppose I compare these two examples in this box. Okay, so I write P1 is equal to W2 RT upon 180. Okay, and here I write P2 is equal to W2 RT upon 60. Now, you only see and tell me in which case the osmotic pressure would be more. You have to look at this. Molar mass is less, osmotic pressure would be more. Okay, molar mass is more, osmotic pressure would be less, isn't it? So in both the cases we come across this, that P1 is osmotic pressure of first solution, that is glucose, is going to be less than the osmotic pressure of urea. Why it is happening? Because its molar mass is more. Okay, hence osmotic pressure is going to be less. Molar mass is less, osmotic pressure would be more. Hence I have written P2 is more than P1. So our answer is this option. Okay, here we have another question which is going to be based on delta TF is equal to KFM. Okay, now but here the ionic solute is already given. Okay, so KCl is equal to K plus Cl minus, it means the number of this I factor is given, it is 2 particles are there. Okay, one molecule is leading to 2 particles. So our formula will become delta TF is equal to IKFM. Okay students, now delta TF is what? Delta TF is T0 minus TF. Now what is the freezing point of water, that is of solvent? We all know it is 0, isn't it? It is 0 degree. Now in this case it is already given to lower its freezing point to minus 6.0 degree. So in this case we don't require to solve, directly they have given it reduces to. So I will not write minus sign because they have already written reduces to. So it is 6.0 degree centigrade. Okay, and as far as M is concerned, for M what do we need? We need W2 upon M2 and mass of solvent in kg. Okay, so this numerical is comparatively very easy. Let us begin. We have to find out amount of KCl, that is W2 we have to find out. So what I will write, W2 is equal to, okay, yes, I'll write first delta TF. Delta TF is equal to IKFM. Okay, then what I will write, delta TF is equal to IKF W2 upon M2 W1 into kg. Okay, now I will remove other terms too on the other side. Okay, W2 I have kept on one side is equal to delta TF into M2 into W1 upon I into KF. Okay, now delta TF is already given. Delta TF is 6. What is molar mass? M2. M2 of KCl. Okay, KCl. Now this potassium is 39 and chlorine is 35.5. So we will get 74.5. Okay, 74.5 I write, and mass of the solvent is given, it is 1 kg upon, then I write here I is 2 particles and KF is also given 1.86. Okay, so when you solve this, okay, 3 and let us keep 3 here only, and using logarithm if you want to solve you can solve, and later on you will be getting answer as 119.95, which is approximately is equal to 120 gram. Okay, just look at the data once again. 1 kg is given, delta TF is given, KF is also given, So when the name of the solute is given, okay, when formula is also given, you can write down the reaction and find out what is the Ventoff's factor. So here we have the question based on molality. 20% of ammonium sulfate means they have given us W2 is equal to 20 grams. Okay. Now what is the molar mass of ammonium sulfate? NH4 twice SO4. Okay. Now here sodium is 14 into 2, 28. 4 into 2, 8. Sulfur is 32. Oxygen is 16 into 4, 64. Okay, so when you add this, you will be getting answer as 28 plus 8 plus 32 and 64 is 132. Okay, so I write here 132. Now we have to write down molality's formula. Now molality would be is equal to number of moles of solute, that is W2 upon M2 into volume of solution in liters, students. Sorry, volume of solvent. Yeah, molality, no, so it is not volume, it is mass of solvent in kg. Okay, now W2 is 20 and molar mass is 132, mass of the solvent. Now see, here it is given 20% solution, means 20 is the mass of solute and 80 is the mass of solvent. Okay, so I'll write here 80. Okay, I will write 80 and kg, no, so I'll have to divide it by 1000. So when you solve this, you'll be getting 1.89 molar solution. Okay, so this numerical is based on the concept of normality. So basically for normality, what we should know? We should know mass of solute. Mass of solute is given, it is 20, and H2SO4, its molar mass when you calculate, you will be getting as, so I'll write here, it is equivalent mass actually, isn't it, into volume of solution in liters. Okay, now how do I solve this? Okay, how do I solve this? We are having over here equivalent mass is equal to molar mass upon the valency factor, isn't it? Valency factor. Now what is the molar mass of H2SO4? H2SO4 molar mass is 98 and valency factor means number of replaceable H plus ions. Now students, it is sulfuric acid, isn't it? It is sulfuric acid. So how many H plus ions are there? 2 are there. So equivalent mass is 49. So I have solved this also. Okay. But what about volume of solution? Density is equal to mass upon volume. Therefore, volume would be written as mass upon density. So please note down this. Now I am going to substitute this in the first given formula. Normality is equal to 20 upon equivalent mass we have calculated 49. Volume of solution determines, I will write mass over here and density over here. Okay. Now I have already written density. Yes. So 20 upon 49, density is given 1.10. So I'll write here 1.10 and it is given gram per liter. Okay, that is given. Now mass is 100 grams. 100 grams. Why do I write 100 grams? Because over here it is 20%. Means 100 gram is the mass of the solution. Okay, and 20 gram is the solute and 80 gram is the solvent. Okay, see, it means 100 grams of solution is there. Okay, but we want 100 grams has to be converted to kg, isn't it? So I write 1000 over here. So when you solve this, it is very easy to solve. You will be getting answer as 4.5 normal. The normality of the solution would be 4.5 N.